right, let's do this next example. So there's actually a couple ways to do this problem. So I'm going to put a line down here just so I can split this in half and do this in two different ways. Both ways are correct. It's just what you see first is what you should do. Okay, so we're going to still do the same thing. We're going to look at, see, we have 10 to the 5 plus 2x. That's the exponential part of our exponential equation. So the first thing we want to do is isolate this exponential part of our equation. So to do that, we are going to subtract the 820 from both sides. Okay, and so when we do that, we're left with 10 raised to the 5 plus 2x. And on the other side, we have 48,780. So now we have the exponential part by itself, and our goal is to solve for x. However, our x is stuck up here in the exponent. So we need to figure out, what do we need to do to get the x out of the exponent? Well, notice this is a base 10, so what if I do a log base 10 on both sides? All right, perfect. We're composing two inverse functions, log base 10 and an exponential function that has a base 10. These will go away, so we're left with 5 plus 2x equals the other side. And then we just have to solve for x. So first I'm going to subtract my 5. And then divide both sides by 2. All right, so this should be our solution. Okay, so that's the first way we can do that, by taking the log of both sides. An alternate way to do that is just to rewrite in log form. So for example, if we go back here where we started, 10 raised to the 5 plus 2x equals 48780. So if I didn't think that I could take the log of both sides, maybe I could just rewrite this exponential equation in log form, right? So if I rewrite this in log form, I will have log base 10 of 48780, and the other side would be the exponent. And then we would do the same thing and get the answer. Subtract the 5 and divide the 2. Same answer, but this way I just rewrote it in log form. All right, let's look at another example. So here, again, we want to isolate the exponential part. That's the e raised to the negative 0.4t. So the thing we need to do is get rid of this 18,000. So we need to divide both sides by 18,000. All right, so if you simplify this, you'll get 1/9 on this side, and the other side, e to the negative 0.4t. Okay, again, we're trying to solve for a variable that's in the exponent, so the only way to get it out is to use logs. All right, so we can use whatever log we want. I'm going to use natural log because I have this e here, so I'm going to take the natural log on both sides. All right, perfect. Natural log composed with e, those are inverses. Those are going to go away. So So we get the natural log of 1 over 9 equals negative 0.4t. Okay, and then just divide both sides by negative 0.4. And that's our t. Okay, so notice that we have these exponential functions and we had to use a log to solve it. All right, let's look at this one. This one looks a little different. 4 to the 2x minus 7 equals 5 to the 3x plus 1. Okay, this is a little different from before because we can't write 4 as something raised to a power to look like 5. And we can't rewrite 5 as 4 raised to some power. So what do we do here? We're kind of stuck. However, we can use our good friends logs to help us out. If you don't know what to do, just try to take the log of both sides and see if that works. So we are going to take the log, any log, I like to use natural log, of both sides. All right, notice we can't cancel these out because we need a base e for these to cancel, but that's okay. We can do other things. We have other log properties. Notice we have inside of our log, we have exponents. We can make them into coefficients. So I'm going to take these exponents and move them to the front as coefficients. So over here we have 2x minus 7 times the natural log of 4. And over here we need 3x plus 1 times the natural log of 5. All right, so we have to solve for x. So here's a technique I was mentioning to you in class that we need to get comfortable with. First, I am going to distribute this natural log of 4 to both of these pieces. And I'm going to do it on the same side. I'm going to do the same thing on the other side, distribute this natural log of 5 to both pieces over here. Okay, so remember, our goal is to solve for x. So it would be nice if I had all of the things that had an x on the same side. So I'm going to move this over and then move the 7 natural log of 4 to the other side. So now all of the things that have an x are on one side, all of the things that don't have an x are on the other side. Okay, again, I need to get x by itself. I notice that it's in both of these pieces. That means I can factor out the x. Running out of space here, sorry about that. That says 7 natural log of 4 over there on the edge. Okay, so now all that's left to do is divide. All right, and this is our x that we were solving for. All right, so notice this technique of, I notice there's an x in both places, so I'm going to factor out and then divide. That will happen a lot in this class.